Hello everyone. In this video we will be revising A-level thermodynamics including heat, temperature and change of state, and in the next video we will be deriving the kinematic equations. So let's get started. Before we talk about anything else in this lesson, it is very important to understand the internal energy of an object. The internal energy of a substance is defined as the sum of the randomly distributed potential energy and the kinetic energies of the particles that makes up the substance. When a substance undergoes a temperature change, the kinetic energy of the particles increases, resulting in an increase in the total internal energy of the substance. This is because temperature is a measure of average kinetic energy of the particles in the substance. Heating an object causes its temperature to rise by increasing the internal kinetic energy. By heating an object, we transfer the energy to the thermal energy store of the object. This thermal energy will be shared among the particles or the atoms of the object and transferred to their kinetic energy stores. Earlier in this video, we discussed that the temperature is a measure of average kinetic energy. Now, what will happen? The particles or the molecules of an object have zero kinetic energy. Or simply, what if the particles of an object is not moving anymore? In this situation, the object experiences a zero absolute temperature. This can be visualized easily using the figure on the top. At the absolute temperature, particles are not moving or they are at a rest. As the temperature increases, molecules gain kinetic energy and they are starting to move. As the temperature gets even higher, molecules begin to move even faster. In 1848, William Thomson came up with the Kelvin scale for temperature. He measured the pressure caused by gas at known temperatures in Celsius and plotted the results. He found a graph like this one on the bottom. By extrapolating his results, he found that the temperature at which a gas would exert zero pressure. Since pressure is caused by the collisions of the gas particles within the container, zero pressure means the particles are not moving and have a minimum internal energy. At this point, the particle stops moving completely and we call this temperature absolute zero. It is not possible to get any colder than this, and this temperature is negative 273.15 Celsius. The Kelvin scale is an absolute scale, meaning it is based off the value of absolute zero. We can convert any temperature from Celsius to Kelvin by simply adding a constant value of 273. When an object is heated whilst in a constant state, the temperature of the object will increase. This increase depends on the energy being transferred, the mass of the substance being heated, and a property of the material known as the specific heat capacity. This can be written in the equation shown in here. The energy is equal to the mass times the specific heat capacity times the temperature change. Specific heat capacity is a property of a material and is a constant for a particular material. This can be defined as the energy required to raise the temperature of 1 kilogram of a given substance by 1 Kelvin without changing its state. It has the units of joules per kilogram per Kelvin. A substance can change state usually when heated or cooled. For example, the ice cream in here is melting down to liquid as it taken out from the freezer because it absorbs energy. There are three states of matter: solid, liquid and gas. This plot shows how temperature changes as the energy increases. Direction of moving arrows show whether the energy is absorbed or released in each process. For example, a substance in the solid phase, When heated, the temperature increases, and this is shown in the inclined blue line. This is because the kinetic energy of the particles increases. As we keep increasing the thermal energy, after some time, the bonds between the particles break, and instead of increasing the kinetic energy, the potential energy of the system changes. At this point, the graph stays flat and the temperature is constant. This is same for the other stages as well. When a substance goes from solid to liquid, this process is called melting, and during this process, energy is absorbed. This is indicated by the direction of the arrow. And when a substance goes from liquid to solid, this process is called freezing and energy is released. The energy required or released during change of state is dependent on two factors: the mass and the specific latent heat constant. The energy can be calculated by multiplying the mass with the specific latent heat. Specific latent heat is a constant for a particular material and a particular state. Specific latent heat is the energy required to change the state of 1 kilogram of a substance without a change in the temperature. So this brings to the end of this tutorial, and in the next video the kinematic theory and the derivation of state of equation of a gas is covered. So if you found this video useful, please subscribe and like for more videos. Thank you.